Welcome to Team 5. It gets a little crazy around here sometimes, but we love to take you on our journey as we build our robot.
Hey!
Yeah, enough of that. Now let's get brainstorming.
In the first stages of the project, we were tasked with building a robot that was capable of picking up rings and then placing them on a pole. The robot also needed to have defense mechanisms against opponent robots who were competing to pick up those rings.
Bring it.
Day 2. Day 3, we are finishing the robot and designing adaptations.
Past couple of class periods, our robot hasn't really been working very well. The motors weren't functioning properly. Today we managed to correct those, attach the claw, add our adaptations, and we're hoping we can add some more next class. Okay, so the first step of the design process is to identify the problem. We had to create a robot that could move things on the ground as well as pick up the rings. The second step is to identify criteria and constraints. We had to use only a kit, so we didn't have so many adaptations to make, and we didn't have access to the 3D printer, so we can only use the laser cutter.
The third step was to brainstorm, and we had to look at all the designs on the boxes and see which one was better for us to use and for our design. The fourth step was to generate ideas. We had to see what we could take away and what we could add to our design to make it better and more efficient.
The fourth step is to explore possibilities. What robot to build out of the box and what to cut out of acrylic. The fifth step is to select an approach. We decided to build a robot with a claw.
Step 7, build a model. Thankfully, we were given the instructions for this part of the project, so we just used the instructions to assemble the robot. However, we were tasked with creating an adaptation for the robot, and we cut this using the laser cutter. Step 8, refine the design. In the final step, we adjusted the arm to make it higher so it could reach all of the rings. We also remade the adaptation to fit onto the robot better.
The advantages and disadvantages of our design is that we have a pusher and a claw that help pick up things off the ground. The claw sometimes can't pick things up off the ground, and we have weak acrylic.
If we were to redo this project, we would make sure that our pusher could collect more ring and attach better.
Comparing and contrasting the project to real-life STEM careers. In the project, it's made of a kit, and we're also able to fix our mistakes. Similarities: trial and error, it's a team effort, and we can adapt to our problems. But in a real STEM career, you have to start from scratch, and it has to be your original idea.